Hello everyone, in this video I will present my regression analysis on the polynomial dataset in ANTA AI Studio. The main objectives are to analyze the dataset, apply different regression techniques with cross-validation, compare model performance, choose the best regressions model, and perform hyperparameter tuning. First, I load the polynomial datasets from the sample data repository here. Okay. The dataset contains one target variable named label here, the green column here. And 5 input features named A1, 2, 3, 4, and 5. These input are used as the variable for the regression models. Because the target variable label is numerical and continuous, this task is a regression problem. The goal is to predict label based on the 5 input feature. Next, I build the regression process manually in the design view here. I built these before. First I use the retrieve operator to load the polynomial here data set here, and then I use the set row to define label as a target variable. After that, I use the multiply operator to send the same data set to 5 different regression model here. The five different regression models are linear regressions, generalized linear model, decision tree, random forest, and support vector machine. Each model was evaluated using cross-validation. This is cross-validation. Inside that, in the training part, there's two. Inside the cross-validation are separated in two parts, the training part and the testing part. In the training part, I use this model as to training the data, and in the testing part, the trained model is applied to test data using applied model, and then performance regression is used to calculate the evaluation matrix. The main evaluation matrix I use is RMSE, which stands for root mean square error. The RMSE measures the difference between the predicted value and the actual values. The lower RMSE means the model makes smaller prediction errors and performs better. So when comparing model, I will choose the lowest one. Here I run this model before, and then I will show you the result here. Okay, as we can see, here's the RMSE, which stands for root mean square error, and this is the result of each model. As we can see, the lowest, I will choose the lowest one, and the random forest model is the model I'll choose. Okay, after selecting the random forest as the best, model, I performed high parameter tuning using optimized parameter grid. Okay, I will go back to design view here, and this is the optimized parameter grid. Okay, here, click here. The purpose of the hyperparameter tuning is to find the best parameter setting for the model. Hyperparameters are settings that we choose before training the model. For random forest, example of hyperparameters are number of trees, maximal depth, and minimal leaf size. For the random forest, I tuned 3 hyperparameters. Here, I edit these parameters in here. I choose a random forest model, and this here, this is the selected parameter I select before. Here in each this the value list I choose, and as you can see here. Okay, I will explain this purpose of these parameters. The first one is the number of trees. This controls how many decision trees are used in the forest. The second one is the maximal depth. This controls how deep each tree can roll. And the third one is the minimal leaf size. This controls the minimum number of samples allowed in a leaf node. If the trees are too simple, the model may underfit. If the trees are too complex, the model may overfit. Therefore, turning these parameters have find good balance. Okay. And I run this. After setting all the parameters, I run this process, and we have the result here. Here's the result. This table shows the different parameter combination test by the grid search. For the number of tree, I test 20, 50, and 100 here. For the maximal depth, I test 5, 10, and 20. And for the minimal leaf size, I test 1, 2, and 5. Since there are 3 values for each parameter, the grid search tests 27 combinations in total. Each row represents one random forest model trained with a specific combination of hyperparameters. The RMSE column shows the prediction error for that. This column. The best value is 52.835 here. So we have the comparison between the before tuning and after tuning. Here the result history. Before tuning these parameter, the RMSE is 60, nearly 60, but after turning the parameter, the RMSE is only 55.8. Yeah, and this shows that tuning improved the performance of the random forest model. So in my conclusion, This project built a regression model for the polynomial dataset, and the dataset variable was labeled, and the input features were 8, 1, 2, 3, and 5. I test 5 regression model using cross-validation, linear regression, generalized linear model, decision tree, random forest, and support vector machine. Based on RMSE, random forest was selected as the best model before tuning, and then I used the optimized parameters grid to tune the random forest model. The best parameter combination was 53's maximal depth of 20 and the minimal leaf size of 1. The final tuned random forest model achieved an RMSE of approximately 52.8. Therefore, I propose the tuned random forest model as a final regression model for this dataset. Thank you for listening.